What's going on, YouTube land? This video is on how to balance a wheel using a lug-centric adapter set. Now, more specifically than just balancing, we're actually going to measure the rim runout, and what this does is check for bends in rims. Oftentimes in the winter, if you hit a pothole really hard with a low-profile tire, or you hit a curb, if you're having vibration issues that balancing is not fixing, the next step would be checking the rim runout to see if something's bent. Now to do this, first thing we have to do is find a centering cone that fits inside the rim. That one's a little too small, doesn't fill in the foot. This one is a lot better. So we slide that on the spindle. The rim is going to go on next. And then the lug-centric adapter. Now if you take a look at this, there's all these different patterns, and this is one of 4 plates that I have. You can see that this is the number 2 plate. This is made for a 5-bolt rim. I have some that are for 4, 5, 6. And you have to look up what peg this needs to go into. In this case, I know it needs to go to the 4.5 inch hole. And slide this part on. And that goes right where the lug nuts would normally go onto. Now normally, we've got the little cup adapter for doing the steel wheels. For using this, we've got to take that off and then use a little donut adapter. And then pull that tight. Now the other thing I should say, this adapter setup is also very common when balancing wheels that have plastic cladding. A lot of your rims now are not actually alloy on the outside, they're a plastic cover, and if you put the cup onto them, you'll actually crack that plastic, which would be another reason to use this. Now I'm going to slide the camera over, take a little bit close up of the screen. Now whenever you walk up to the balancer and you start this, I always like to start fresh, hit the R twice. Brings us to the home screen. We're going to select balance. And once we're there, we're going to arrow down until we get show, run out, and quick matching. Now the upper one shows the lateral rim runout, which is side to side. This next diagram shows radial, which is going to be up and down. And then it also shows if you want to do quick matching, which will be another video, the improvement after quick matching. What we're going to do is measure rim runout, which is this one here. And it shows me I need to put my left arm on the inner lip of the rim and the right arm in the same place. So this left one's going to go right here, and the right one, now this rim doesn't have a lip for a weight to get hammered on the outside. It uses tape weights. So this little piece spins up and down. So this would be if I had a steel wheel I was measuring, I turn it upside down, now I can do the alloy wheel. I'm going to place this on the inside of the rim like that. This one on the lip of the rim where the weight would normally go. And at this point, both my hands are holding these pieces in place, so you hit this black button here, and that's going to start the machine. Now it gets a little noisy for a minute. It's kind of a rough sound. Alright, and what this is showing me right now is I've actually got quite a bit of movement side to side, and I've got 88 thousandths of runout up and down. I like to go to the show runout plots, and this is where it really gives you a good idea of where our problem is. As you take a look at this, you can see that white line there. My rim's nice and straight all the way across, and then I hit this point where I've got a big bend in it, and that's going to be my problem. As I rotate my wheel, you'll see that red arrow at the top. That represents the top of my wheel. So when I get to this point, that is right where my bend is going to be in my wheel. If I go over to my rim, and you take a look right here, you can see the black mark, and that's where I have a pretty significant bend in this rim. You can see a little bit there, the bend in it. So this was a rim that had to get replaced because it hit a pothole and it bent the rim enough that the driver could still feel the vibration, and the only option was to replace the rim. Now the nice thing about this is after you measure a rim, you can go up to the customer and show them exactly where the bend is, how significant the bend is, and it makes justifying the cost of a new rim a lot easier. So this video showed you how to set up the balancer to do rim runout measurement. You can do the same thing on a steel wheel. I just did it on an alloy one because it's a little bit easier to see. If you have any questions, throw them up on my comment section. Thanks for watching.